Good day, Junior Techies. This is Mr. Lodge, and in this video we will be looking at elements, at compounds, and at mixtures. Now, as we saw in our previous video, all substances are made up of atoms. What we are going to be looking at in this video is how we group the various substances together. So we're going to be looking at the differences between the pure substances and mixtures firstly. That is our first way of grouping substances. Now, in a pure substances, there's only one type of particle. I'm using the word particle, but we could also use the word molecule. In a mixture, there are two or more types of molecules. We will go on in this video to elaborate on that. We then make a further distinction when we look at elements and compounds. Now, elements, as we know from our previous video, are made of atoms, all of the same kind. We will look at compounds in more detail in this video. So, just to recap what we covered last time, we saw that every element is made up of the same kind or a unique atom. So all of the atoms of copper are unique to copper and they are identical to one another. On the other hand, if we look at the element lead, all of the atoms of lead are unique. They are particular to lead. They are not the same as any of the other atoms on the periodic table. Last time we touched on the periodic table. Let's go back to the periodic table to discuss this very important tool that scientists have for arranging the elements in a way that we can predict their behavior. This, as you know, is known as the periodic table of the elements. Now, every symbol on this table represents a unique type of atom, which the particular substance is made up of. And they are arranged from the lightest, which is hydrogen, over here, to running across and all the way down to the most heavy atom, which is over here. Now, while we are busy with the periodic table, I would like to draw your attention to certain elements which occur in a particular way. They always occur with two of their atoms joined together. So, if we have the little circle, the little red circle standing for one atom, it's always bonded to another atom of the same element. These are known as the diatomic elements. So we're going to write out that word, di, which means two, diatomic elements. And we're going to show you where they lie on the periodic table. There are 7 of these diatomic elements, and they lie in the shape of the number 7, which makes it easy to remember where to find them. So here we go. The first one is hydrogen, and then we move across to nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, which gives us the shape of the number 7. And these should be learnt off by heart. Now, the idea of two atoms joining onto one another brings about the idea of a molecule. A molecule is a group of atoms, two or more atoms, which are chemically joined to one another by means of a bond. Let's have a look at our first example over here, which is ozone. Ozone is made up of 3 oxygen atoms, 1, 2, 3 identical atoms bonded together to form ozone. Now, because these atoms are all oxygen atoms, for that reason, ozone is an element. But that's not the only way in which molecules are formed. It is possible for different atoms to bond together. For instance, here we have sodium bonded on to chlorine to form a new substance called sodium chloride. It is bonded in a ratio of 1 sodium to 1 chlorine atom. And this is known as a compound. When we have different atoms from different elements bonded to each other. Let's have a look at the concept of compounds in more detail. One of the key issues in a compound is that the ratio in which the different atoms are chemically bonded is always fixed. They bond together in a fixed ratio. So, for instance, water, in the water molecule, we always have 2 hydrogens bonded on to 1 oxygen, as is shown in the example over here. So that means that water is a compound because it is made from 2 different atoms, 2 or more different atoms, which are chemically bonded together in the fixed ratio, 2 hydrogens to 1 oxygen. Carbon dioxide is another compound because it is made up of 2 different atoms, carbon and oxygen, bonded in the ratio 1 carbon to 2 oxygens. That's why it has the formula CO2. And lastly, salt, as I've mentioned, is NaCl, which bond to each other in the ratio 1:1. Let's spend a little time talking about how we write down the formula for substances. Because water is always in the ratio 2 hydrogens to 1 oxygen, we write down the formula as follows. The hydrogen, capital H, that's the symbol for hydrogen, and oxygen is the other element which is involved in the formation of water. And the ratio of hydrogen to oxygen comes below as a subscript at the bottom of the hydrogen. It's not necessary to write the 1 for the oxygen. It's best to leave it out. This brings us back to our classification of matter, of substances in general. we have looked so far at the pure substances. Pure substances, we remember, are only one type of particle. So one type of particle or one type of molecule. So all of the elements are pure because they consist of one type of particle. All of the compounds are pure. For instance, salt, NaCl, is pure because in pure salt you will just get many salt particles, but no, it's not mixed with any other type of particle. If we were to put salt, which is NaCl, and if we were to mix it with water, which is H2O, and put those together, we would now have a mixture of, that is salt water. So we're going to spend some time looking at what mixtures are now. Mixtures, by the name of the word, indicate that we've got more than one substance mixed together, but they are not chemically bonded. So here are some examples. If we look at steel, steel is a mixture of iron and carbon. So there's a certain percentage of iron and a certain percentage of carbon, which gives steel its particular properties. If we change the ratio of iron to carbon, we get different properties of the steel. Let's have a look at bronze. Bronze is also a mixture. It's a mixture of copper and tin. We combine them in a certain ratio to get what is known as an alloy, which is a mixture of the copper and the tin. A very common example that we are familiar with is air. Air is a mixture mainly of nitrogen. The second most prevalent component is oxygen, and then lastly carbon dioxide. Now you'll see when we look at the picture of the air, we see there are lots of different types of particles in the air, and that indicates that we have got more than one type of particle, so air is a mixture. As another example, we can look at concrete. Concrete is a mixture of stone, which are the quite big particles in the concrete, sand, which you can barely see with your eye, and then lastly there is cement, which fits in between the sand particles. So concrete, because it is made up of these three components, is a mixture. So let us stop for a moment and look at elements, compounds, and mixtures. So looking at some examples of elements, things such as gold, copper, oxygen, chlorine, and diamond are all examples of elements. They are made up of only one type of atom. Let's turn our attention to compounds. Examples of compounds are water, salt, carbon monoxide, baking soda, quartz crystals. These are all compounds because they are made of more than one different type of atom which is chemically bonded together. Mixtures are substances such as salt water, air, cake, milk, all living things such as trees and animals and plants. Let us finish our video with some examples of elements and compounds and mixtures. Now, the first distinction to make is, are all the particles the same? And if we look here next to elements, we see that in the first box, every particle there is a small red circle. So that means that it only contains one type of atom. So it is an element, and it's pure because there's no other substances in that box. Likewise, the second box over here this is a diatomic element because it consists of two atoms of the element bonded together. If we look now at compounds, we see that every molecule that is in this box is identical. Because it's identical, it is a pure substance. It is not a mixture. A mixture is when we have more than one substance mixed together. These are compounds. The green little circles I have made around them are all compounds. They are particles of the compound because they are made up of more than one type of atom. Likewise, in the second example of the compound, here we have two different atoms joined together. Now, the elements in the compounds are different from mixtures. There's a major difference in that these are pure substances because every particle is exactly the same. Whereas in the mixtures, let's turn our eye to the example of the mixtures, and we will see an array of different types of particles. So here we've got a compound mixed with a diatomic element. Those are the two different types of particles over here in the mixture. Okay, so here there's two types of molecule. If we look at this example over here, there's two different types of atom that's not bonded together. So these atoms here are not bonded together, two different types of substance. And likewise, over here, we've actually got more. We've got about 4 different substances in the final example here of a mixture. If we have a look there, we've got the red and the blue bonded together like that. We've also got a diatomic in the mixture. Like that. we've got some single atoms in the mixture, like that. So we've got a number of different substances. So here we have got a mixture of pure substances, a mixture of different substances. Junior Techies, thank you so much for watching this video. Be on the lookout for our next video on the particle nature of matter. Thank you.